Hi everyone, my name is Laman Gafarzada. My serial number is 10,355 and I'm going to show you how to solve my hard problem, which you see here. Integral from z to pi over 2 x cotangent x dx. As you see, we found u, and because of u we can find the derivative of u, which is 1. That's why we only write dx. And dv is dv is cotangent x, and we all know that cotangent x equals to cosine x divided by sine x. And we need to find v, the value of v. For finding value of v, we need to find integral of cosine x divided by sine x dx. I called u as sine x, and the derivative of sine x equals to cosine x dx. And from this expression, we can find dx, which is du divided by cosine x, and we put this value to right here, and we finally got this expression. And as we all know that integral of 1 divided by x dx equals to ln x, that's why we only write ln u, and we put the original value of u, which is sine x, here, and we put v equals to ln sine x. So now we can apply the rule of integration by parts. It's expression right here, and we put the real values right here. And I prefer to find it in separate parts. Firstly this part, secondly this part. Let's find first part. First part, we see that x ln sine x, natural log of sine x. For finding it, we need to put pi over 2 and 0 into x. When we use pi over 2, it equals to ln y multiple pi over 2. And we all know that ln y is undefined, that's why we can use it. When we use 0, it equals to 0. But instead of using 0, I prefer to use limit x approaches 0, x ln sine x, and equals to 0. And because of this, we understood that it's equals to 0, and we need to find the second part. Second part, actually I called it a part, and we know this rule: if x equals to fx minus a, we can apply this rule right here. What's our a here? Pi over 2. We put pi over 2 sinus pi over 2 minus x, and we know that pi over 2x, sinus pi over 2 minus x equals to cosine x. So we find two a values, first and second part, which is equals to each other. When we find the sum of these expressions, we find this. And we all know that ln a plus ln b equals to ln ab. We can put these sinus x cosine x in one integral. So we find this expression. And sine x cosine x, for finding this, we all know that sine of 2x equals to 2 sine x cosine x. We find that sine x cosine x equals to sine 2x divided by 2. And we put this expression right here and find this expression. And then ln a divided by b equals to ln a minus ln b. That's why we can separate both parts here according to this rule. And we get this expression right here. So for finding this one, I put u equals to 2x, and that's why du equals to 2 dx. And we know that when we put 0 instead of x, u becomes 0. When we put pi over 2, u becomes p. That's why we can easily write this expression here, integral from 0 to pi, blah, blah, blah. Then, we know that because of this expression, we know that we can replace u with the x. That's why we wrote x instead of u. So, we found this expression. After this, we know that if integral is from 0 to a, we can easily put 2 outside of the integral and divide a by 2. So, when it's possible, it's only possible when fx equals to fa minus x, and we prove that fa minus x equals to fx. So we can apply this rule right here. 2 are eliminated, these 2's, and we got this. From this expression, we called this, as you remember, a. That's why we can easily see that this is a. A minus pi over 2 ln 2 is equal to 2a. Why 2a? Because we put it here 2a. So a equals to minus pi over 2 ln 2, and we remember that our expression was like this, and this is minus, so it makes it positive number. That's why answer is positive pi over 2 ln 2.